Next example, we're solving quadratics using the quadratic formula. First step, what do we have to do? Set it equal to 0. Very good. So, I add 10 to both sides, and I'm now equal to 0. Okay, now what do I need to do? Label A, B, and C. A is 1, B is what? Negative 7, and C is 10. Okay, Lance, you okay? Writing this example down? Here we go. So I got those labeled down. Connor, what am I going to do now? Plug them in. All right. So I'm going to write the formula again for you. Negative b plus or minus the square root of b squared minus 4ac all over 2a. There's the formula. I'm not going to write it anymore, but I'll write it one more time for you. Now that I got the formula and I got a, b, c, now I got to plug it in. Negative 7 plugged into negative b is going to turn into what? 7. Plus or minus the square root of 49 minus 4 times 1 times 10. Where'd 49 come from? Can't you do that in your head? Yeah, so when we said there was a lot of steps last example, yeah, there were, but you can start trimming some of those steps. Okay, you can trim, right? You know that negative 7 squared is 49. You don't really have to write every single step. Somebody thought that this was 2 minus 1 last period. What does that dot symbolize? Multiplication. Okay, that's 2 times 1, which is just 2. You can start eliminating some of these tedious steps. Now what do we need to do? We need to do the discriminant, the stuff underneath the parenthesis, underneath the radical. 49 minus 4 times 1 times 10 is going to be what? 49. All of that is going to work out to be what? 9. So this is 7 plus or minus the square root of 9 all over 2. Bells should be going off. Yay! Why are we happy? Because 9's a perfect square. The next example is not going to be. Okay? But in this example, we get a perfect square. It's 9. So what do we get?
7 plus or minus
7 plus 3 over 2 and 7 minus 3 over 2. There's your plus and minus. We broke them up. Why did we break this one up? Because we had whole numbers. Because we didn't have any radicals. Because we didn't have any i's. You break it up. I break up over here on this side. I get 10 over 2, which is what?
5.
X equals 5. Over here I get -4 over 2, which is what? 2. Positive 2, not negative 4. Positive 4 over 2. So I get 5 and 2. So my question is, would this have factored? If I worked it out, would it have factored? Well, is my discriminant 0 or a perfect square? Yes, it is. See, it was 9, so it would have factored. The next one's not. I wanted to do 2 easy ones before we moved into the other ones. Okay? Questions? Any questions? We got one more example. Here we go. Let's make that a positive 6. Let's make that a positive 6. All right, so here we go. First step is what, Reed? All right, so when I move the 6 over, what is it going to become?
Negative.
It's going to be negative. Sometimes you might have to combine like terms. You might have to do more than one step. We're just doing one step. All right, so now, what is A, B, and C?
1, negative 7, and negative 6.
A is 1, B is negative 7, C is negative 6. All right, so we go to plug in. We get 7 plus or minus the square root of 49 minus 4 times 1 times negative 6. All over 2 times 1. All I'm doing is simply plugging it in. I did one step. I squared B. That's all I did. Melanie, what do I do now? You have to simplify. You're exactly right. So what simplifies?
Multiply -4 times -6, and then you get +2.
You're exactly right. And this is where people make mistakes. Guys, the most critical thing in this entire problem is this stuff underneath the radical. If you get that wrong, you can hang up getting the right answer. You have to get it right. And most people mess up when there's multiple negatives. If I have negative 4 times 1 times negative 6, she's exactly right. I get positive 24. And 49 is sitting out there, and so, correct me if I'm wrong, I think I get 73,
Yes.
if I'm not mistaken, right? So you add and you get a bigger number. Right here, I still have 7 plus or minus, and on the bottom, I still have 2. Can I do anything else?
No.
Everything stops. Why does it stop?
Because it's a perfect square.
Because 73 is not a perfect square. It's, in fact, it's prime, right? I don't think anything goes into 73. So we stop right there. There's nothing else I can do. I can't cancel anything. I can't simplify anything. X equals all this stuff. And the reason is because that's not factorable. Because the discriminant equals 73, right? Then you get this ugly kind of answer and you're done. That's all you can do.
So you just leave it like that.
You would leave it exactly like that. Okay? What if you're working the problem out and you got 4 plus or minus the square root of 18 all over 2? Let's say you got to this step. What would you do then? Could you go further?
Yes.
You better, right? Some of you didn't yesterday on the quiz and it burned you, right? The square root of 18 can be broken down into what?
3
3 root 2 all over 2. Now are you finished? Can you cancel anywhere? I got a 4, a 2, and a 2. Can I cancel?
No, because
the other
3.
one.
Why not?
The 3.
I'm not looking there. Why?
Because
It's underneath the radical. I have to have it there, there, and there. So, if my answer would have worked out to be 6 plus or minus 4 root 3 all over 2, could I simplify then? I'm sorry, it's crooked, but could I simplify then? Yes. Why? Because I have it there, there, and there. I have it in all 3 places. Then you can simplify. All right, here's the question. What if this was negative? How would that have changed my answer? I need to put an I where? After what number? After the 3. After the 3, there's an I right there. See, we've already done this. We did this chapter 1 when we did complex numbers. We've already broken things up. That's why the quadratic formula, that's why I knew we could cover it on a Wednesday, review it on Thursday, and test on Friday. We're still okay. It's not that difficult. Okay? You guys, if you follow the 4 steps, you should be fine on quadratic formula. Okay? Any questions? Anybody have any questions about it? All right. We're going to stop here.